Namaste to all. This is me, Shreya Bamihar, and this is the channel of mainly about the physics topics. And I'm I have completed MSc Physics from the Rani Channamma University. And in this channel, I'm going to upload all the physics topics which are related with the degree, PUC, or MSc topics. So, without wasting much more time, I'm going to start today's class with the low pressure physics, that is rotary pump. Let's start the video. As I mentioned earlier, so in today's session, we are going to discuss about the low pressure physics. Actually, for a BSc 4 semester for Rani Channamma University, they have given the both the things, low temperature as well as the low pressure physics. From that, I'm concentrating only on the low pressure physics. So in the low pressure physics, I'm going to discuss about the rotary pump. I think you know that low pressure nothing but creating the vacuum inside a chamber. Okay, so in the same way, we need to know the definition for a rotary pump. What the definition stands here, a rotary pump, commonly called a rotary vacuum pump, is a mechanical pump used to remove air or a gas from a closed vessel to create a vacuum, or it is called as a low pressure. What it is saying, so rotary pump usually called as a rotary vacuum pump. Why? Because this rotary pump going to create the vacuum inside the chamber. Vacuum nothing but the space or the area which not have any air particles or any gas particle. It should not have any particles inside that vessel or a container or a room. Okay, that we call as a vacuum. It's completely empty. So so usually we call as a rotary pump as a rotary vacuum pump is a mechanical pump. I think you know that production of electricity is usually done by the wind energy, hydropower plants, okay, from the thermal energy. So by this we can also know that, so mechanical pump nothing but we are using a mechanical way. Mechanical nothing but there is a rotation. The word itself is saying rotary nothing but rotations inside the pump. What is rotating, how it is rotating, okay, all those things we'll learn in the working and under the construction thing. Okay, so here we are using a mechanical pump used to remove air or a gas. As I said you earlier, vacuum nothing but it should not contain any air particles or a gaseous particles. To remove these air or a gas particles, we are using a mechanical pump from a closed vessel to create a vacuum. So where we are creating the vacuum, we are creating the vacuum under a in a sorry not under, it is in the closed vessel to create a vacuum. So inside the closed vessel, what we are doing, we are creating a vacuum nothing but we are removing the air or a gaseous particles. Fine. So vacuum nothing but here we are saying it as a low pressure. I hope definition is clear for you. So this is very simple definition. Rotary pump is that we also know commonly called as a rotary vacuum pump, is a mechanical pump used to remove air or a gas from a closed vessel to create a vacuum nothing but it is a low pressure. I hope definition is clear for you. Next we have a, it works using rotating mechanism inside a sealed chamber. Why we call it as a sealed chamber nothing but we are using a closed system or a closed chamber. From this closed system or a closed chamber, we want this to be vacuum. We want it to be empty without any air or gaseous particles. So this works on the rotating mechanism. Why we are calling it as a rotating? So now we'll get to know. Next we have the construction of this rotary pump. So first part is cylindrical casing. So cylindrical casing nothing but this is the outer jacket of our rotary pump. Next we have a rotor which is rotates inside a casing. So in this cylindrical casing, this rotor start to rotate. So that's why we call it as a rotary pump. Next we have a vanes. Vanes nothing but sliding blades attached to the rotor. So whatever rotor is there, no, for this rotor there is a attachment of the sliding blades. These blades start to rotate, then only this rotary pump start to work. Then we have an inlet valve to take a to for a air intake. Okay, next we have a outlet to remove air or a gas from a rotary pump, okay, or from the seed chamber. All reservoir it is used for the lubrication purpose or to avoid the friction of the sliding blades to the cylindrical casing. To avoid the lubrication we are using a oil reserve. I hope this construction is clear for you. Next we are going to learn about the working of this rotary pump. See, this is very simple and very easy to understand. Okay, so don't go for the diagram. This is a rough diagram. So the actual diagram will be displayed on the screen. You can see that. Okay, see, if you see this carefully, this outer jacket look like a cylindrical casing. So how the cylinder will be, in that way this outer jacket looks. That's why we are naming it as a cylindrical casing. Fine. So here if you observe carefully, we have a intake suction, nothing but there is a entering of the air, and next we have a rotor. So you can see it, so circular part which we called as a rotor, and here we have a outlet where the air is, excess amount of air is removed out. And next we have a sliding vanes. Now whatever these blades are here now, so these are called as sliding vanes. Next we have a shaft for a rotating purpose, and this is all about the parts of our rotary pump. So now what happened, from the seed chamber which is attached at the intake, here we have a seed chamber which is attached to the intake section. So here what happened, there air enters the rotary pump. From this air will enter the rotary pump. So while entering of the air, now what happened, the volume of air is going to be increased and pressure near a intake section will be decreases. Volume increases, pressure decreases, then air enters the rotary pump. First point is volume is going to volume is going to increase, pressure is going to be decreased, so then air enters the rotary pump. Now what happened, these sliding vanes will carry forward a air or a gas particles. It will take the air inside the rotary pump over here. Now what happened, at the outlet section or at the exhaust valve, what happened, these slides will move here. So from here there is a decrease in the volume and automatically there is a increase in the pressure. By this there will be created a vacuum inside the chamber. So now what happened, this here air will be entered, and for that sake the volume is increased, pressure is decreased, so this air is carried forward. Okay, when it reaches the exhaust valve, there is again decrease in the volume. Why? Because the air is moving outward. So almost all the air or a gaseous particles moving from the exhaust valve. So at that time volume is going to be decreased and pressure is going to be increased. This process continues periodically. It goes continuously. This process goes on. Okay, understood. So at that time rotor continuously start to rotate, and that for a rotor the shaft will be helping for a rotation. So cylindrical casing is the outer jacket which helps for this entire process. I hope you got the working of the rotary pump. If you have any doubt, you can ask me in the comment box. So thanks for watching. Keep subscribing. Take care. Bye bye. I hope you understood the working of a rotary pump. This is all about the today's session, that is definition of a rotary pump. So we got the definition of a rotary pump, then we got to know about the how it is working. This is working on the rotating mechanism, and then we saw the construction. So what are the things we have in the rotary pump, Then we studied about the working of a rotary pump. This is a very simple concept. I hope this entire session was clear for you. If you have any doubts or any queries, you can ask me in the comment section. Thanks for watching. Keep subscribing.